Hi everyone and welcome to Miss B Maths Teacher channel. Today I'm going to talk about integration and I'm going to show you how to find the area under a curve using one of the methodologies that have been used by the ancient mathematicians. Later on in different video I'm just going to use a few rules to find the area under a curve, but for now for the first one we're just gonna go use something that is called lower and upper rectangles. So again, before I start this, I'm just gonna have a look at some graphs that you have seen before, and if you need to find the area under the line, for example in this case, and if I go okay, I want to find the area between 1 and let's say 3. So you may use for this one something that is called graphical evidence. So, and you can recognize, okay, these shapes here, it does look like trapezium. So and I can use the area of the trapezium to find this area under this line. Same here. So looking at this graph here, again, graphical evidence can be used because that would be the easiest way to do it. And let's say this is A and B, and find the area under this line. You're looking, okay, this is triangle, so I can use the area of a triangle in order to find what is the area under this line. And the last one we have here 1/4 of the circle. So you find 1/4 of the area of a circle, and then you can find the area under a curve. So you can see, like, if slope is constant, like in the first two examples, so it's easy, to find the area under a line. For this one here, even though the slope is not constant, but we can recognize the shape. So it's like, we can use graphical evidence to find the area under this curve. Now, so what's going to happen if we do have a curve like the one here, so like this one here, and we have been asked to find the area under this curve. So so what's going to happen? So we're looking, okay, for example, if we want to find the area between, let's say, 1 and 4, between 1 and 4, and this graph here is y equal to x to the power of 2 plus 1. So please remember, f of x is equal to y. So you may say, okay, so it does look like trapezium. So and yeah, so it's not exactly trapezium, but if you have line here, something like this, like, okay, we can use the area of trapezium, but then we are left with this area here. So we would have some approximation of this area, but it's not the best estimate. So therefore now we're looking, okay, so what else can be used in order to to find this area. And this is where the lower and upper rectangles are gonna come handy. So what I'm gonna do first, so we're gonna go with lower, but before we do that, so we want to find the area between 1 and 4 under this line, under this curve. So, and what we're gonna do, this interval here from 1 to 4, okay, this is interval. So we're gonna divide this into 3 strips of with 1 unit. So we're gonna do something like this. I'm gonna use it. Yep. Okay, dividing. So now we have like 3 equal width. So, and each of these is 1 unit. So we do know from 1 to 2 is 1, from 2 to 3 is 1, and from 3 to 4 is 1 as well. So now let's have a look, what's going to happen with this lower, I'm just going to write here, okay, lower rectangles. rectangles. Okay, so now how are we going to create those lower rectangles? So pretty much what we're looking here. So if we have this graph here, this line here, so and in this interval from 1 to 2, we are looking, where's the minimum value of this curve in this interval. So the minimum value of this curve is, I'm just looking for different color, it's here. Okay, so it's the minimum because you can see that this is y value here, and this one here is that one there. So like this is the one, this is another one. So this one is lower, so it's lower y value. So we're gonna choose that one, and by choosing that, we're now gonna create rectangle. So, and we're gonna stop there. So now, okay, so that's one rectangle. So the next one, we're looking between 2 and 3. So looking between interval from 2 to 3. The length is 1 anyway. So, and we're looking, okay, is this point with minimum value, or if it's this one here? So yeah, of course it's this one there. So we're gonna go like, okay, so that is the minimum one, and we're just gonna have a line, that's parallel to x-axis, and we are creating another rectangular shape. So that's gonna be another one. And then again with the next one for the interval between 3 to 4. So where is the minimum value of y? Is it this one or is it this one? So of course it's this one. So we're just gonna label that one and then create another rectangle. So, and it's gonna be okay. So this is what we have now. So we have created 3 rectangles. So to find the area, the total area, so we're gonna use AL is equal to, and I'm gonna use yellow, so it's representing, this area. L, it is, how do we find the area of the rectangle? So it is, isn't it? Like, base times height, base times height, base times height, or you can call this length. So what is the length between 1 and 2? We already said is 1. Okay, so this is, the length. So, but what is the height? What is the height, this one here? So we can say, so that if this x is 1, when x is 1, we have to calculate f of 1. Is that correct? Okay? So f of 1, f at that point. So, and this f is given there, okay? So it's given there. So, but, for now, we're just going to be 1 times, so times f of 1 plus, now another one here, from 2 to 3, it's again 1. So it's again 1, and times f of, so you just have to be careful, it's at 2, okay, because this is the height, not here. So because the height of 3 is there, so it's this one here, f of 2, and then plus 1 times, and this one is f of 3, f of 3. Now the next step would be just to calculate. So now what I'm gonna do, I'm gonna use this, f of 1, f of 2, and f of 3. I'm gonna calculate that on the side. So this one here, the one that I'm just circling. So you can do it like here, straight away, calculating here, but I'm just gonna do it on the side. So and let me use blue. So y is equal, f of x is equal x to the power of 2 plus 1. So when x is equal to 1, f of 1 is equal 1 to the power of 2 plus 1, which is equal to 2. So it's 1 times 2 plus 1 times f of 2. So f of 2 is equal to 2 to the power of 2 plus 1 is equal to 5. So times 5 plus, what is the last one? So the last one is f of 3. So it is 3 to the power of 2 plus 1 and is equal to 10. So it's 1 times 10. So when we put all this together, it's going to give us 17 units to the power of 2. Just please note, like if you're wondering how did I get, this 10 and f of 3. So this is the function here that's given. So that is the value of y. So f of x. So that is our y. So every time x is going to change, we change the x, y will change as well. So this is our lower rectangle area. So it's 17 units. But we can see here there's some bits and pieces like there that, haven't been calculated. So, this is our, estimate approximately, it's 17 units. How we can, have better estimates? So the next step we're going to use to say, use upper rectangles. So f of 2 here, it's 5. So f of 3. Yes, we do. I'm just gonna write here, upper. So upper, and it is similar to one before. So I should have drawn this picture, before. I'm just gonna say this is 4 as well. So I'm not even. That's good. So it's same. To subdivide, so go between 1 and 4, we're gonna have all this length. It's gonna be each interval is gonna be 1 unit, so that's gonna be the width. And now similar with the lower one, now we're looking between 1 and 2. So between 1 and 2 here. So between 1 and 2, we're looking, what is the maximum value of the curve on that sub-interval. So is it this one or is that one? Is this one? And now we're going to create rectangles. So we're going to go to the left because we're talking about the interval between 1 and 2. So the same is happening with 2 and 3. Between 2 and 3, you're looking which value has the maximum value. So, and it is the one at 3. So is this one here. And again, we're going to create another rectangle. So, and same's happening with 4. Okay. So this one is higher or maximum. So we're going to have another, rectangle. So now we have 3 again. And this one is a upper. So is equal to, what is the base? It's 1, isn't it? Okay, length or width. So it's 1 times f of, so at what value of x we had the maximum? Was it at 1 or 2? So yeah, it was at 2, not 1. So therefore, we're going to have f of 2 plus 1 times f of, so what's another one? So it's between 2 and 3. So was it at 2 or was it at 3? It was at 3. So f of 3. And the last one, you can see it is when x is equal to 4. So 1 times f of 4 equal to 1. Now we can do the same here. F of 2 has been already calculated. So we have just use that one. So 1 times 5 plus 1 times, let's have a look in. So 1 times 10 and plus 1 times, we just need to calculate f of 4. And remember this one is f of x is equal x to the power of 2 plus 1. So 4 to the power of 2 plus 1, it is equal to 17. So times 17. When we add all this together, we're going to end up with 32 units squared. So now what do we have? It's, the upper area. So pretty much what we can conclude that our area under the curve between 1 and 4, it is bigger than the lower one and it's less than the upper one. So area, our one is bigger than 17 and it's less than 32. So This is not a bad estimate, so but definitely it can be improved. So what do you think what may happen if we actually, instead of 3 subintervals, we have 6 ones? So instead of, for example, you can see here we have 1, 1, 2, 3 intervals. What's gonna happen if we have more 6 intervals? So, and each width is gonna be just half. I'll just let you think about it. So what will happen? So if we create more subintervals, the estimate AL and AU will become more and more accurate. So what is happening as the subintervals width is reduced further and further? So if we have half or quarter, so I'm just going to write that one, both A, L, and AU will converge to A. So converge to A. So it's gonna, move towards to A. It's gonna be close to A. So I'm gonna show you another example. Using this example but with more subintervals in another video. So I hope you enjoyed watching this and it does make sense to you. Thank you for watching and I'll talk to you soon. Bye.